Hi, this video is about exploratory data analysis sports performed on Indian Premier League datasets. Thanks to the Spark Foundation for giving me this opportunity. And next few steps, I will take you through the analysis I performed on those datasets and the inferences I found through those data. And I'm a newbie to the data science world, so I welcome your feedback. So to take you better, the exploratory data analysis, as you know, is an approach to analyze the data sets and summarize the characteristics. I have did the same, and in addition to that, I also, you know, perform some hypothesis testing to ensure that the characteristic shown by the data is really valid, or is that really a invalid statement. Okay. So the contents, what we have is all about the project description, analysis, dashboard, outcomes, and the statistical verification, as I told you. So the project description is all about performing EDA on the data sets. There are two data sets. One is delivery and matches, and those data sets need to be analyzed, and we need to identify the most successful player, team, and its contributing factors, and suggest a team and a player for a company to endorse its products. So the analysis which I did, I will take you through the analysis screen. Yep. Okay. So I have what I did is I have imported the relevant Python libraries. I have used pandas to read the dataset and then verify the anomalies in the dataset. So that those are the next steps. Then what I did is I created a batsman stats from the deliveries dataset. So that's what it is all about. So here I just took a uh, created a new data frame for the total runs scored by the batsman, and I have sorted it out. And this particular table is all about calculating the batsman strike rate and adding it to the existing data frame. And then the next few steps is all about calculating the the number of centuries hit by a batsman, half centuries hit by a batsman, fours, six, and then merging those data sets, data frames into a common table, and finally arriving the batsman stats. So here what you see is the batsman stats. So it lists about the and it's sorted on based on the total runs. So it says who is the top batsman with the total runs, and it also gives the information of the of that batsman in terms of strike rates, number of centuries, half centuries, number of sixes hit, number of fours hit, and this is visually seen through pie plot. So if you look at the below screen, the graph shows the total number of runs scored by the top 10 players, stands with the, and then moving down it brings the strike rate, and as I said, number of the most number of sixes, most number of fours. Then I moved down to analyzing the bowling stats. Bowling stats, I also looked into the delivery data set, and then I took based on the number of dismissal counts. This is for LPW. Moving down, it's for the number of wickets taken by the bowler, catches, and then I merged all those data sets, and these two data frames speaks about the stumping and the catches. So this summarizes the bowling stats, and if and it is all sorted based on the total number of wickets. So, and this is visually seen through the pie plot with the top 10 bowlers with their highest wickets. total wickets. Moving down, I did the same thing for wicket keeper, analyzing the number of stumpings and the catches from the delivery data set. And the same thing has been visually seen through pipeline. Then I moved further in analyzing the matches dataset, identifying the player of the match and the highest number of um, um, count in terms of the players. So this stats provide the highest player who received the man of the match, the most man of the match awards, and this has also been visually seen. And finally, I went through identifying the most successful teams um, from the match dataset, and this has also been visually seen through PyPlot. Further, what I did, I identified the match wins per toss from the match dataset. So this shows um, the list of teams who won their matches based on their toss wins or toss loss. And this is also examined via PyPlot. And I pulled the winning stats based on the toss decision, whether it is bat or field, and the winning stats based on the toss decision and the team playing on their home ground or away. From the results, it is evident that Kohli has scored the highest total number of runs, and the strike rate. Andre Russell has the highest strike rate, and Chris Gayle has the most number of sixes. Shikhar Dhawan has hit the most number of fours, and Chris Gayle has obtained the most number of player of the match awards. And Malinga is the best bowler. MS Dhoni and Karthik, stands from the wicket keeper stumping and catches perspective, and the most successful team in the IPL stands with the IPL, and most successful chasing team in the IPL is Kolkata Knight Riders. And the contributing factors for the win and lose, I found from the stats that in the toss, winning toss has a significant contribution on the winning teams. This has been shown on the pie plot as well. I'll just take you through that. So if you look at the total, on toss stats, Mumbai Indians, Chennai Super Kings, and Kolkata Knight Riders were the maximum, toss wins, and they stand on the top list of the total number of, players. Um, yeah, most successful teams. If you look at the most successful teams, Mumbai Indians, Chennai Super Kings, and Kolkata Knight Riders rank on the top three. So definitely, toss win has a significant contribution to the success of a particular team in the IPL of winning a match. And the second contributing factor for winning a match is playing on a home ground or playing away from a home ground. So the most number of matches played by Kolkata Knight Riders and Mumbai Indians on the home ground has given them a significant um, increase in the number of matches. So the contributing factors for win and lose is evident that toss and playing on a home ground or away are the two important significance. And this I tried to prove it via hypothesis. What the hypothesis is? I have hypothesis is just we assume the null hypothesis that there is no relationship or association between those variables, and then we statistically prove that that is true or false, right? So I used three statistical models. One is chi-square test, second is one-way ANOVA, and third is independent sample t-test. And the null hypothesis I've taken on both the cases is there is no relationship between toss decision and win or a lose of a match. And the second case is there is no relationship between the ground team player, a player playing in the ground in their home ground or away and winning a match. So I'm taking you through the chi-square test for the case one. So what I did is I used Pandas crosstab for the toss decision, and I have used analyzed data as the data frame for this. And I have selected two columns: toss decision and win. And then I observed the observed value, um, followed by which I have imported the Skype stats library. So the CS2 contingency, it says what is the ideal value for it and what is the observed value. Expected and observed value is what it shows through. So the expected value is 140, 152, 222 and 240, whereas the observed value is 159, 134, 204 and 259 for this particular metrics. Going down, I just print out the degree of freedom with this calculation, and then I import chi-square library from the Skype stats, and it provides the chi-square statistics value. Further down, I just calculate the critical value using the alpha, which is assumed as 0.05, and then using the degree of freedom for calculate the critical value, followed which I calculate the p-value. So here the p-value is 0.0006, which is less than the significance value, which is 0.05. So we need to, in this case, we need to reject the null hypothesis. So definitely there is a relationship between the toss decision and winning and losing a match. So the case one, provides a proof that there is a relationship via chi-square. Let's move down to the case two, which is verifying the relationship between the home ground, a team playing in the home ground or away, and winning and losing a match. Here I took two columns, which is win and the ground from the analysis data frame. Similar way, if I calculate the observed value, and then finally I come down to the p-value. Here the p-value, it says 0.65. 0.65. So the p-value here is higher than the significance value. So we need to retain the null hypothesis, which means that there is no per chi-square, there is no relationship between a team playing in the home ground or away and winning and losing a match. So further down, I perform the same hypothesis testing via one-way ANOVA, and here for one-way ANOVA we need to change it to a category variable. So I've taken three particular variables: toss decision, ground, and win. So toss decision, ground, I've taken as a independent variable, and I'm verifying it against the dependent variable as win. So I've changed everything to a categorical variable. I'm showing it. So if you see here, the toss decision will be a categorical variable, win will be a categorical variable, and ground will be a categorical variable. Then I find the correlation between that. So if you see the correlation between toss decision and a win, it is 0.009, which is less than 0.05. So there is definitely a correlation. And then with respect to ground and win, there is minus 0.015. So I use one way. I import stats library from Skype package, and then I perform with the f1 way function, providing the three values, and then I calculate the F statistic and P value. So if you see here, the F statistic is 73 and the P value is, very less than, 0.05. So it statistically proved that there is a relationship or association between the toss decision and the win or lose, and the team playing a home ground on the win and the win or lose. So I move forward and take you through the final hypothesis testing, which is independent sample state test. Here I once again, I have already imported the stats, so we don't need to worry about that. So this is a function which I use t-test int, and then I provide them all the values. So here I test between case one, which is the toss decision, and case two, which is a team playing in a home ground or away, um, whether it has an association with winning or losing a match. So if you look here, the p-value again in both the cases are less than 0.05, which means that there is definitely an association between the toss decision and winning or losing a match, and the team playing on their home ground or away and winning their match.